Hello, good morning once again. So in this video I'll demonstrate the use of DSCH2, that is design schematic. So this is the window DSCH2. I have opened it. There is a palette here. So this is for designing a schematic and converting that into Verilog, simulating it, seeing the behavioral, uh, the description of the circuit and the working of the circuit. So let us try to learn it by drawing a schematic of a full ladder circuit. So full adder circuit will have an XOR gate, drag it like and an AND gate with the half adder. So let me connect this uh, like this, and there are two inputs, and to take connection from the middle of a line you have to make a connector like this and then draw a line. Okay, so now this is crossing over this line, but there is no connection here, but there is a connection here, okay, because there is a dot. Alright, so let me minimize it a little bit. Okay, so a full adder will have another half adder circuit like this. Um so it needs a two input, another two input XOR gate. Okay, and an AND gate, two input AND gate. So this, the output of this first XOR gate is connected as a sum 1 between C in is given to the other input of it. Alright, so there is uh, this is like this. This is the XOR gate, the second half adder. So let me connect like this. These are connections. Okay. So now the outputs of two AND gates, the carry 1 and carry 2, they have to be connected through an OR gate. So an OR gate is required. A two input OR gate. Uh, so this is connected this way, and okay. Now this completes the schematic of uh, a full adder, which is having three inputs: A, B, C in, carry in. This is a sum out. This is a carry out. Okay. So let us try to, we can simulate this, see the working of this by adding say for example buttons to the uh, inputs. Say this is input 1, input 2, and input 3. So to the outputs I connect a LED. Okay, so two LEDs I'm connecting here. So let me rename this. First one, this I call as C in. Okay. C and say, let me color it as uh, yellow. Okay. And other input I call it as A, red color only. Another input I call it as B, color red. Okay. Now output, this output is sum, and this output is C out. Okay. There is right. See. Now it completes drawing of the schematic. Now we can simulate this. How it simulate this? Go to simulate, start simulation. Okay, here something is running. You stop it here. So what you can do is you can just click on this. Say A. A is high, B is low. That means A is 1, B is 0, C in is also 0. So then sum is 0, 1 and carry out is 0. Output is 1, 0. If you add say two ones together and C in is 0 and A and B are high, so then C out is 1 and sum is 0. You'll get 1, 0. Output as 1, 0. When all the three inputs are high, then you'll get 1, 1. So this way you can check if only one of the input, two of the inputs are high, then you'll get 1, 0. If only one output is high, then you'll get 0, 1. If all outputs are high, then you'll get 1, 1. So that is a full adder circuit verification that you can do in this. So so many other things that you can do in this. Say a timing diagram. So there is a timing diagram here. Uh, I started from. Okay, so when so you can see here, see A, B, C in. When only A is high and B is 0 and C in is 0, you'll see that sum is 1 and carry out is 0. So when at this time, say both A and B are high, but C in is 0, so you'll see that C out carry out is 1 and sum is 0. When both when C in and B are high and A is 0, so you'll see that only two inputs are high, then you'll see that carry out is you know 1 and sum out is 0 here. So like that you can see that. Okay, so there is one more interesting thing that you can do. You can convert this schematic diagram into a Verilog file. So that is quite interesting. So which you can use for simulating in Xilinx, or you can convert the Verilog file to directly to layout. That you can see in micro:bit. So first let us try to convert this schematic into Verilog file. That you can do here. Go to file, make Verilog file. See, it's amazing. It made the Verilog file. So there are so many things here. So there are two XOR gates, two AND gates, and one OR gate. So there is something, some numbers you see here, hash 23. What it may. So it means that XOR gate is having the rise delays and fall delays is 23 time steps. So it's 23 nanoseconds, and here 16 nanoseconds is a rise delay and fall delay. So if you don't want this delays, gate delays to be there, so you can unselect this so that no delays will be there. And there is another few more lines are added here. This for this is a stimulus. It's a test bench for verifying the behavior of the circuit in Verilog. So if you don't want that also, you can unselect this, so those lines won't be there. So it is formed only the module, the design description with the name of example. Example is the name of the schematic there. So it is formed with that name only, the module name. Okay. Say okay, then it will be saved as example schematic. That we can see later when we convert that into the layout in microwind. So that is one more interesting thing that we can do in this. So well, that's it. Now this is what. So in the next symbol, you can make a symbol of it. You can make a symbol of it. Say for example, you want to use this full adder as a block for designing a 4-bit binary adder, and then some higher order circuits. Then for that, you can make it. You can assign a symbol to this entire circuit. So assign a symbol to this entire circuit. There is a schematic to new symbol. Okay, so these are the pins. You can give a name to that. A symbol is given here. Name symbol 10. It is there. Idle sim 10. It is saved. It will be saved in a directory. So you can say okay. It will be saved as symbol 10. And that symbol 10 can be used for designing another higher order circuits. For example, if you open a new circuit altogether, so in this you want to insert the symbol. What was the symbol that we used? Uh, Symbol 10. Okay, so this was the symbol for full adder circuit, and you want to construct a 4-bit binary adder by making so many symbols like this. Four times you can insert, 4 times you can insert, and connect them the way you want. So that forms uh, a 4-bit binary adder consisting of 4 full adder circuits. Okay, so the carry out is connected to the carry in of the next level. Okay, like this it is connected, and some are taken out. So this is a second actually. So these are a C in is given as input, final C out as taken out as the most significant bit of the sum out. So we are adding two 4-bit numbers, A, B. This you can rename them like A1. This is A0, B0, A1, B1, A2, B2, A3, B3. Okay, this is how you can construct a 4-bit binary adder, and you can verify it, and you can make a Verilog file out of it. These are the things that you can do with the DSCH, design schematic. So that's all for today. I'll see you in the next video. Bye bye.